In this presentation, we're just going to go over the practice problems from the previous week. So here are the answers for those problems. So let's just do like we were doing before and just take this step by step and just follow the process that I'd given you in the previous examples. So let's just draw our vertical line here and then put what is in our logical sequence in the truth tree. Remember, our premises are the things that are on the left side of the therefore sign, this thing here. And we're going to put them on the left side. And if I remember right, I was using green to show true. P wedge Q. And remember, left side is true, right side is false. And then what we want to do with our conclusion, which our conclusion is on the right side of the therefore sign, is put it on the right side of our truth tree. So that's how we start these things out. So now what we want to do is go through our premises and break them up following our rules. So we're looking at our first one up here. Our I'm going to do yellow. Looking at this premise right here. So it is or I guess first we should be asking ourselves, what's the main operator here? So what's the operator that's operating on the whole statement? And we only have two choices. We have the tilde or we have the arrow. So it's one of those. So since there aren't any parentheses around the P arrow Q, it's got to be the arrow because the tilde is just attaching to this P. So really what we have is we have the, try to clean this up again, those lines. So in case you're having difficulty determining what the main operator is, so this tilde is only attached to this thing here. And so we have two sides that are connected to the arrow. So that's what makes the arrow our main operator. So then we have to use our arrow rules to break this thing apart. So if you remember when we were doing the rules previously, what makes an arrow true? And we're asking ourselves what makes it true because it's on the left side here. So what makes an arrow true is whether or not the left side, or sorry, is if either the left side is false or the right side is true. So we've taken care of this. Now we gotta just look at what else we've got in this line here because we've got a tilde still. So we just have to break that down one more time. And if you remember, for tildes are the easiest ones. You just take what you have on the one side, you flip it over and get rid of the tilde. So we just get rid of this tilde and flip it over to the other side. So tildes are the easiest by far. And so now we've taken care of this. Now, let's just look at this other one. How many operators? Well, it's only got the one. It's only got the wedge in it, so we know we're going to use our wedge rules. And so what makes a wedge true? Because it's on the left side. It's wherever one of them are true, or either the left side's true or the right side's true. Remember, or suggests that we have to branch out. So we have to do this on both of our branches that we've already got created. And so we want to put the P and the Q here. And same thing here. The E and the E and the Q. So this has to get repeated on every branch. And that's just the same thing done twice. We just have to take everything that we do above and put it into each of the branches below if it happens before another break. So that is as far as we need to go with this, because our conclusion is just a Q, so there's nothing more to break down. So let's look at our different branches here. Remember, the whole idea of doing truth trees is to determine whether or not the sequence is valid or invalid, and we determine that now by going back through each of the branches and seeing if there is a contradiction. A contradiction being that the same thing appears on both sides of the line, both on the left side and on the right side, somewhere up the branches. So let's look for this one right here, this branch, and we could see we've got a P on the left, a P on the left, and a Q on the right. None of those cancel out. So remember, when you don't have a contradiction, we just put a circle there saying that it's open, and then we can move on to this next branch. We see a Q on the left, a P on the left, and a Q on the right. So that one does close because we have Q here and a Q here. One's on the left, one's on the right, so it cancels out. So that one's closed. Now let's look at this one here. I know it's going to be open because I see there's a P on the left, Q on the left. Actually, no, fine, I take that back. There's a P on the left, a Q on the left, and a Q on the right. So these two, again, say to me that there's a contradiction, that this can't be possible. And actually, since it appears up there on that branch, I know it's going to be the same thing here. So now, let's just follow through, and then I want to show you something that's interesting about this truth tree. And that can be a little bit of a shortcut in the future. So, we do have an open branch, namely this one. So we know that it's going to be invalid because as long as there is one branch, if there's one branch that's open, it's an invalid sequence. And so how do we, or what do we need to do next? Well, we need to provide a counterexample, and we need to provide the truth values for P and the truth values for Q when it is invalid. So the P's on the left and the Q is on the right. Oops. Right is not a truth value. False is a truth value. There we go. So that's how we just do that problem and determine whether or not it's invalid and produce the counterexample. Now, something that you could have done on this one is stop this branch here. So after we broke this one up. So remember when we broke this one up? Some of this other stuff. So when we broke this one up, this was the result. The not P went on the left hand side or on the right hand side, and the Q when we broke up the arrow, and then we had to just switch the P across to get rid of the tilde. So what you can do on a step-by-step basis is go back through your truth tree to see if something closes it off. So since I have this Q on the left hand side and my conclusion is a Q on the right hand side, I could have automatically closed it off once I got to this point. And then I wouldn't have had to take this one and put it down here like I did before. it's not necessary at this point because it's automatically going to close off whatever follows below it. So it's a little trick that you can use to make your truth tree smaller, and the added advantage is that you can do a truth tree and break things up in any order that you want. So if you see something that's going to provide you a contradiction to close off a branch, you can go ahead and exercise the rules on that thing and then just close it off, and then you don't have to worry about putting the other stuff that you have to do later in the truth tree underneath of it. But if you just if you're just wanting to try to understand what we're doing right now, just follow the step-by-step process, because the way in which I had it before, when I had it like this is equally right. So the nice thing about logic is, as long as you follow the rules, you'll get to the same result, which is this, and that is what we're shooting for. So, and what I'll be testing you on is whether or not you're using the rules right, not if you made it as optimal as you could or as efficient as you could. I'm just looking for whether or not you followed the rules correctly and got to the right answer. So, whatever works best for you, you can do. I just wanted to show you that little trick for the future, if you felt like you could use it effectively. Now let's look at this one. So, same thing as before. We have our premises here on the left-hand side. We have our conclusion here on the right-hand side. So we'll list the premises. And then you. Something tells me I'm going to need a bit more space on this one. So we'll try to do that. Alright, so let's just do like we have been doing and start with our premises in our first one. So we'll start here. What is the main operator in this sentence? So we have two again, we have a tilde, and we have an ampersand. Now what's different about this one is the P and Q have brackets around them. They have the parentheses around them. So the saying in this parentheses is a single thing, and we're negating everything that's within these parentheses. So that means that what's operating on the whole statement isn't the and sign, but it's the tilde saying not all of this stuff. So let's go ahead and flip that across. I'm going to just drop the parentheses because we don't need them at this point. And remember, when you do a tilde, all you're doing is taking this and you're flipping it across and getting rid of the tilde. That's all we did. So now let's just stay focused on it. We have an ampersand, and we're saying that it's false. What makes the ampersand false? Well, that's if either one of the conjuncts is false, if the left side or the right side is false. So since it's an or, we gotta split it up. And I just said if one of them is false. So remember, false on the right side, true on the left side. So that's breaking down this one. We flipped the tilde, or we flipped over the statement and we got rid of the tilde. And then we looked at what makes an ampersand false. Well, it's if one of the two sides is false. Since it's if either the left side's false or the right side's false, we branch out, put them on their own branches, and so that is how we do that. So that one's taken care of. So now we know this one's good. So let's focus on this next one. Same thing as before. Well, you have parentheses and the tilde saying not all of this stuff. So we're going to flip it across and just get rid of the tilde. And remember, we have to do this on both sides of our branches. So anything we do above a branch, we have to put it down in each of the lower branches. So I'm just taking this thing and I'm putting it here and I'm putting it here. Now, what makes an OR statement false? Because we have two things. We have the or we have the tilde. Which one's the main operator? Well, the tilde now is just applying to the P, so that means our Q is our, or sorry, not our Q, but our wedge is our main operator. So what makes a wedge statement false? Because it's on the right side. What makes it false is if both sides are false. So if not P is false and Q is false, not P is false, or sorry, Q is. So we just took this, broke it down, using our rule. What makes a wedge false is if both sides of the wedge are false. So we just stack them below, keep them on the right side's false. Now, the last thing we need to do for this one is, since we have a tilde P, we have to flip tilde P across our line to get rid of it. So we just took this thing here and we flipped it to make just the P. Now we can say we are done with this one. Now the last thing we need to do is break down our conclusion. Oops, sorry. Not that one. Didn't mean to do that either. Go. Break down our conclusion, which our conclusion is just a tilde P. So, to break that down, we just need to flip it across. So now, even though we just repeated what we just saw up here, we still need to do it because we haven't broken it down yet. So this P is coming from that. This one is coming from those. So even though we repeat ourselves here, we still have to do it. And now we've broken everything down. So let's go back through our two branches and see if we have a contradiction. So we have a P on the left, Q on the right, and a P on the right. Well, right there's a contradiction. Clean this up so I can highlight it. Yeah, a P on the left, P on the right. So that's our contradiction. So that one closes off. So now let's look here. We have a P on the left, P on the left, Q on the right, Q on the right. That's it. So both of our Q's are on the right, both of our P's are on the left, so there aren't any cancellations because we don't find either of the letters on both sides of the line somewhere up the proof. So that one is also open. Or not also open, but is open. What I meant to say is that this problem is also invalid. Our last one was invalid, this one is invalid too. Remember, when we have an invalid truth tree, we have to provide a counterexample. Our counterexample is going to come from our open branch, and we need to list values for each of the letters that are in our logic sequence. And so that could be P and Q. My P is true because it's on the left side. My Q is false because it's on the right side. And that is that. So let's move on to the third one. Same process as before. Premises are on the left. Our conclusion is on the right. Circle. There we go. So let's draw our line. Let's put our premises on the left-hand side. Put them in black, but my apologies for that. I'll start using out to stay consistent. So let's just start with our first premise. Again, we got to identify what the main operator is. We got three different ones. We have the ampersand, we have the arrow, and we have the tilde. So the ampersand is in between two parentheses, so that's telling us that that's not the main operator. Our tilde is attached to the R, not the whole statement, so that's not the main operator. So our main operator is the arrow. So what makes an arrow true? Remember on our rules, which again you're just going to have to memorize, make sure you have them in your notes. So these are just our rules. What makes an arrow true is if the left side is false or the right side is true. So now we do still have a couple operators we got to deal with. Let's look at the one that's on the left hand side. So we have a ampersand. I can get rid of these parentheses now because I don't need them. So what makes an ampersand false is if one of them is false. If the left side's false or the right side's false. Let's go ahead and do this one because we got a tilde P. Remember, with tildes, we're just flipping it across. So what I just did there, I broke those down, this one, and flipped it across. And now that gets rid of this one. So just to follow this again, just before I move, what we did first was we broke down our arrow here, and then we broke down the individual parts, this part and this part, here, and those aren't P's, that's an R. And I write down the right letter. So now let's look at this one. So what makes an ampersand true, and we got to do it on each of our branches, is if both of them are true. We got to do it branches. So again, we just repeat the same thing on all the branches down below whenever we do something that happens above it. So we just have to repeat the same thing on all the different branches. That's why you see QP, QP, QP on all of the different branches that are on here. Now, we broke that one down, so that one's good. So now we just have to look at our conclusion, which is just a tilde R, and that just says, hey, flip it across, but we got to do it all of our branches. So we'll take our tilde R, we'll flip it across. And same thing applies as before. We write it on all of these branches because we're doing something that happens above the tree and putting it down into the lower branches once we break it up. So now I want to look back and look to see if any of our branches are closed off. So we'll start here. We got a R on the left, we got a P on the left, we got a Q on the left, we have a P on the right. So right there, those two will cancel out to give us one closed branch. Now let's look at the next one. We got an R on the left, we have a P on the left, we have a Q on the left, we have a Q on the right. We have two things that will cancel out right there. X there. Now we got an R on the left, P on the left, Q on the left, R on the right. Two things that will cancel out. And since all of our branches close, then that tells us that this is valid. And we don't have to provide a counterexample because if it's valid, it's just valid. We'll do this one like we've done the other ones. So here are our premises, here's our conclusion. Let's just go ahead and list them. Premises go on the left. Q, Q, and R. E goes here. So we're just taking our conclusion, taking our premises on the left, but the conclusion on the right, and that's how we start every single one. So let's focus on the first premise up here. What's the main operator? Well, we have our parentheses here telling us that's one whole thing. So that means that the double arrow is conjoining the P and the R or not Q. What makes a double arrow true is if they both match. So wherever they both match, if P and then R or not Q, if they're both true or they're both false. So remember, for the double arrow, if they both match, it's true. If they don't both match, so if they're different from each other, if the left side's true and the right side's false, or the right side's true and the left side's false, then it's false. So double arrow, matching true, not matching false. Now, if you wanted to use my trick from before, we already see that we're going to have a contradiction here. So really, you could go ahead and close this off and stop doing stuff if you wanted to, because you know you're going to have a contradiction. But in the interest of just getting as much practice as we can, I'm going to act like I don't see that. So I'm going to keep breaking this down. I'm going to get rid of these parentheses right here because I don't need them anymore. So I'm going to focus on this true, this left side one for right now. So what makes a wedge true is wherever one of them is true. So either the left side is true or the right side is true. So wedges, if one of them is true, it's true. And then we just need to do this. We have to work on this, which is just flip it over into a Q over. For tildes, you just flip it across the line, get rid of the tilde. I'm going to try to save myself a little bit of room because something tells me I'm going to need it as we keep moving down through this. So that one, that premise is done and taken care of. So now let's look at the next premise. We have P or Q and R. What's the main operator here? Well, it's the ampersand. It's the and sign that is conjoining the things that are in parentheses and are R. So that's going to be our main operator. We have to do everything that we do above in each of the branches below. So what's the ampersand rule for a true? Well, it's wherever both of them are true. If the statement is true, then both of them are true. So I'm going to put everything that I'm about ready to do in each of the branches. So PQ, I'm just get rid of parentheses. And actually, I just realized something. Sometime this is probably a good teaching point. Now, it's because I still haven't done what I needed to do with this. So let me hold off putting this over here. Just gotta back up entirely, actually, because I still need to do this right side from the uh, first premise. So I still need to take care of this, which I haven't done yet. So should have double checked. I need to take care of this. So what makes an OR sign false? Because our main operator here is our OR sign. So what makes an OR sign false is where they're both false. Q. And then I just need to flip that not Q, the line, to make it just a regular color. Again, trying to save a little bit of room, so just to follow that, I broke this down over here, but I needed to break this down further. So breaking this down gave me these two, and then I flipped the tilde over the line there. So now we've taken care of the first one entirely. Now we can go back through and add our second premise here. Same thing as before. P or Q on P. So now we have the same thing everywhere again. That's just getting reflected. I'm breaking down this premise in all of my lower branches. So that's why you see the same thing everywhere. Whenever you do something above, you got to put it in everything below. So now we just need to break down this P or Q on each of these branches. So what makes a wedge true is where one of them is true. Gotta do the same thing everywhere. So all of this looks the exact same. Why does it look the exact same? Because we're breaking down the same exact premise in every single branch. That's why it all gets repeated. But it has to get repeated in every branch. So now we can go back through, since our conclusion is just a single letter, there's nothing to break down there. Now we can go back through and look for contradictions. So let's just start over here. I've got a P on the left, R on the left, R on the left, E on the left, E on the right. As I told you before, everything's going to close off on this side because I already have my contradiction here. So as I travel up all these branches, I'm going to see, oh wait, I've got this contradiction. Oh wait, I've got this contradiction. Oh wait, I've got this contradiction. Of course, I've got this one as well. But no matter what, I know it's going to close off all these branches because I have this P on the left and P on the right up here. You could have used these two here. It's neither. It's not really a big deal. As long as you close it off, you would have got to the same answer. So all of these are going to close off. So now we just got to look at our right branch here, which is P on the left, R on the left, and Q on the left, R on the right. Well, right here, it's a contradiction. That one's going to close off. And the same thing's going to be true right here. So they all close off, which means that it is valid. And there's nothing else for us to do. There's no counterexamples needed since it's valid. We're all good. Here, you might be wondering, well, how come if we repeat a lot of things that we do, why does this side have 4 and this side only has 2? Well, remember that what made this happen was the fact that we had a wedge that was true here, and a wedge that's true is an OR. It's either the left side's true or the right side's true. And we had our wedge false here, which is a stack rule because both of them have to be false. So that's why we don't have as many branches on the left-hand side as we do on the right-hand side. So what we do on each side does matter and influence the number of branches we see at the end, just in case you're like, where's the symmetry at? But so this one's valid, and all the branches close off. So in this instance, we only have one premise, and of course we only have one conclusion, so it's going to, our truth tree at the very beginning is going to look something like this. So, a little bit smaller one this time. Let's just go ahead and focus on our premise first. It's on our left-hand side. So, what's the main operator here? That should be our question. Well, we have tilde on the outside of parentheses. If you remember, parentheses are saying all of this stuff, and the tilde is saying not all of this stuff. So, we'll just flip it across our line. So, just take statement. I'm going to get rid of the parentheses. Need them. So, our tilde here is our main operator because we have these parentheses. And we just took it, we flipped it across, got rid of the tilde, and I just went ahead and got rid of the parentheses. Remember, they're sort of operating there, but you can get rid of them if they're a little bit confusing. Typically, it's just easier to get rid of them once you don't need them. If you keep them there, it's not a big deal. Your notation, as long as it's correct, is perfectly fine, and it's correct if there are parentheses there or not. So, we still need to break this one down further. So, what's our main operator? Well, it's going to be our arrow, because our arrow is connecting this side with this side. So, what makes an arrow false? An arrow is false wherever the left side is true and the right side is false. We took this one, left side true, right side false. Broke that down. Now we just need to flip this not Q across the way into A. So it's Q, it's changed into that. And now that is everything we needed to do for that premise. So check mark that if we want. So now we just got to look at our conclusion. And our conclusion, what's the main operator here? What's the ampersand? Now you may have not seen two tildes together, but that's completely fine. That's just saying not a not Q. You can have an infinite string of tildes. Well, maybe not an infinite string because it's got to be finite at some point, but you can have as many tildes as you want in front of a letter, and it's just keeping on not. But this is still one thing altogether. So our ampersand is our main operator, and what makes an ampersand false, again, it's on the right side, is if either the left side is false or the right side is false. Now, we just need to take care of this double negated Q. And what we do is we flip it across and get rid of one of the tildes. So really what we're doing right now is we have this thing. And we're getting rid of the tilde by flipping it across. But we got to keep this other tilde because it's part of it. Now, we still have this other tilde. So we got to flip it across again. So, whenever you have multiple tildes, you can only flip it across once, or you can only get rid of one as you're flipping it across. And then you have to flip it across again and again. So the one thing in the logic is that you have to do everything one step at a time. That's what we did here with this one. So this is looks like everything we need to do for the conclusion. So we can go back through and look for contradictions. Try to erase some of this stuff. So we have a P on the left, or sorry, P on the right, and a P on the left. That's going to close that one off. Now I have a Q on the right, and I don't even have anything else. I don't have a P. I got a P on the left up here. Oh, and I got a Q on the left up here. Sorry. I got a Q on the right. I got a Q on the left. So that will close off there. And so this statement is also valid. Again, you've seen me get caught up twice now. So truth trees can be a little tricky, and they're a little tedious. There's a lot of work that goes into them and a lot of tracking. So just make sure you double check on everything when you go back through them. So again, we've got our two here and our two here. Just close them off. So that is that one. Alright, so let's do this sixth one. Same thing as before. We've got our premises on the left. We've got our conclusion on the right. So let's go ahead and put them down. E double arrow R Q E arrow Q R. Let's take this down a little bit further. So let's just start with our first premise. What is our main operator? Well, we have this tilde attached to this P. We have a set of parentheses, so it's got to be the double arrow. So what makes a double arrow true is wherever both of them match. So either both of them are true. Actually, I'd get rid of parentheses right now. Both of them are false. And again, I'm just taking this right here. I'm just getting rid of the parentheses when I'm putting them here and here, in case you're wondering where those are coming. So now let's focus on the left side. So I've got a not P. I try to save myself a little bit of room. Just put the P there. So just flipping them across. Much more there. Let's look at this wedge. What makes a wedge true? Well, it's where either of them are true. So we'll break it apart. R here, Q here. Again, I can go back through and I can already see that I've got a contradiction at least right here. Got an R and R, and I could go ahead and cut this branch off and not have to do anything else below it, but in the interest of just following a procedure, doing as much as we can, I'm just going to keep going with that branch as we do the other premise. So I need to do the right side now. I'm going to flip this P across, so this P turns into this P, and we just have to do this wedge. What makes a wedge false is wherever both of them are false. So stack them. Q. That's that. So now we've taken care of everything that we needed to here and everything in all of our branches. So that premise is done. So let's focus on the second premise. What's our main operator? Well, we got a tilde that's attaching to this P, and we've got a tilde that's attaching to that Q. So what's holding them together is the arrow. So what makes an arrow true is wherever the left side is false or the right side is true. And I'm going to repeat this in every branch. Q. E. So again, all of these match because I'm breaking this thing down, this arrow down. So that's why we see them in all the different branches down below. So whenever you do something above, you got to break it down stuff below. So now we just have a lot of flipping to do. We have to just flip these tildes into regular letters, which I'm just gonna do this. So all I did was flip these across to get rid of the tildes. So now we finished this one, so we're good. Conclusion doesn't need anything because it's just a letter by itself. So let's look to see what we've got, if we've got any contradictions. So we got a P on the left, R on the left, P on the right. So there's a contradiction. P's on the left, P's on the right, so that one's closed. Go back through this branch. We got a Q on the right, we got an R on the left, we got a P on the right, we have an R on the right. So got one here, got here, so I got an R on the left there, I got an R on the right there, so that one's going to close this one off. Now I got a P on the left, Q on the left, P on the right. So I've got P on the right, P on the left. That gets rid of that one. So that closes that off. Let's go back through. Here we've got a Q on the right and a Q on the left. So that one's going to close that one off. So now let's look at these branches over here on this other side. I've got a P on the left, Q on the right, R on the right, P on the left. Not seeing anything that's closing off. I got a P on the left, Q on the right, R on the right, P on the left again, R on the right again. So, oops, that was just supposed to be a circle. So that one is open. And I've got a Q on the right, Q on the right, R on the right, P on the left. Again, that one is. So, there are no contradictions in this branch. So, since I have at least one open branch, that tells me that this is going to be invalid. And if it's invalid, I need a counterexample. And I need to provide truth values for all the letters that I have in the problem, which is P, Q, and O. So, I'm just going to pick this one. So, I got a P on the left. So that's true. I got a Q on the right. That's false. I've got an R on the right. That's false. So it's invalid, and my counterexample is where P is true, Q is false, and R is false. So that is that problem. Same thing as all the other ones. Here are our premises. Here's our conclusion. So let's list it the same way we have been. I'm going to try to save myself some room here at the beginning. Vertical line. So I want to put my first premise up here. And then my second premise, and then conclusion. Like so. So let's just do the first premise. I've got these two sets of parentheses saying that these two things go together. They'll get connected with a wedge. So what makes a wedge statement true is if one side is true. This a little cleaner here. So either the left side is true or the right side is true, like that. So put the left side here, put the right side, or sorry, put the left side here, put the right side here. I'm just gonna focus on this P and Q for a moment. So what makes P and Q true? Well, if they're both true. So if P and Q are true, it's true. So they will stack. There we go. Now let's look at our other part of our first premise. So we have this and this being connected by the arrow. So what makes an arrow true is wherever the left side is false or the right side is true. I'm going to go ahead and flip this not R, this tilde R across the way, change it into just a regular R on the other side. And so that is that first premise. That is all done. Now let's look at our conclusion, because this premise doesn't need anything. So this one is what we need to focus on now. So we have a not R and P. So what makes an ampersand false is where one of them is false. So not R, P, and I gotta do this on each of the branches. Not R, P. P. So again, just to show you, this is all the same thing, all coming down from here. Because whatever happens above has to be put down below. So now the only other thing we got to do is flip the R across on all of these, and now we're done. So we can go back through, look for contradictions. I've got an R on the left, Q on the left, a P on the left, and another Q on the left. So nothing is going to close off there. I've got a P on the right and a P on the left. So I do have a contradiction here. And close that one off. Then I've got an R on the left, R on the left, and a Q on the left all the way up here. Nothing's going to close off. I've got a P on the right, Q on the left, Q or R on the right. Sorry. Like I said, these things can get a little confusing. P on the right, R on the left, Q on the left. So nothing is going to close off there. Then we need to look at this one. I've got an R on the left, Q on the left, Q on the left. So nothing closes off there. I got a P on the right, Q on the left, Q on the left. So nothing closes off there. So now we need to go back through, create a counterexample. I'm going to pick this one over here. So it's invalid because I have at least one open branch. I actually have a bunch of them. So I need to, again, provide truth values for each of the letters that appear in the actual tree. I'm going to focus again, like I said, on this one right here. So I've got an R that's on the left. That's true. I've got a Q that's on the left. That's true. I've got a P that's on the left. That's true. Now you may have realized that there are a couple more branches that have different values, which I could have done here, where P is false, R is true, Q is true. I could have written P equals false, Q equals true, R equals, true. So I could have done either of those as a counterexample. I wouldn't have traced any of these other branches back because I only have a P and a Q here. I only got an R and a Q here. Like, I want a branch that has all three letters in it to be able to provide this counterexample. So here, I could have done either of these. You don't have to provide both of them, but either one of them would have been right. If you would have provided the top one, it's fine. If you provide the bottom one, it's fine. So as long as you provide one instance in which you have an open branch and you can tell me the truth values of all the letters in the logical sequence. So I've got R, P, Q. Those are the only letters that you see up here. Then you're all good. Doesn't matter which one you use as a counterexample, just as long as you use one of the open branches and list values for each letter that's present in the logical sequence. Same thing as before. Premises on the left. Conclusion's going to be on the right. We match that down here with P arrow, R double arrow, M and N, R arrow, N and M. Let's do our first premise first. So, got a lot of operators here. We got arrow, double arrow, M. Don't get too flustered by this because, again, got a set of parentheses there putting all this together and this. So, let's just do the arrow first. So, the arrow is true wherever the left side is false or the right side is true. I'll go ahead and drop this first set of parentheses. So even though this looks really complicated at the beginning, I'm just writing it one step at a time. So parentheses are telling me that, this whole thing on the right-hand side of the arrow is one thing, and then there's the P, and they're both joined together by the arrow. So that's what's telling me the main operator is the arrow. I have to do the arrow first. Have to. Can't do the double arrow first, can't do the ampersand first, have to do the main operator first, which in this case is the arrow. So now let's focus on this part of the tree. So again, we have parentheses telling us that that side goes with this side. So our main operator is the double arrow. What makes a double arrow true? We've done it enough times now in this presentation that it is where both of them match. So either both of them are true or both of them are false. And now we just have to do these two parts of it. So I'll focus on this one first since it's on the left-hand side. Read left to right. So what makes an ampersand true is where they both are true, where they stack. And over here, what makes them false is where one of them is false. So again, if you're a little bit confused about why I'm making the moves I'm making, you might want to look back at your notes or at the previous presentation when I outlined each of the rules for each of the operators. If they're on the right-hand side, they do a certain thing. If they're on the left-hand side, they do a certain thing. You just have to memorize those rules and exercise them accordingly. So again, if you're struggling a little bit at this point, make sure you're fresh on those notes. Make sure you get that because it's just the same rules that get applied again and again and again and again and again. So make sure you're comfortable with those rules. That's what I'm doing here. So back in on this problem now. I'm done with this premise. I've broken it down as far as it will go. So nothing I need to do with this premise because it's just a single letter. So let's look at our conclusion. Conclusion here. Remember, I got the parentheses making this whole right side something and this left side is getting connected with the arrow. So our main operator is the arrow. And what makes an arrow false? Well, an arrow is false where the left side is true and the right side is false. I gotta put this in every branch. And so I just like highlighting this so I make it clear that this is just this rule getting broken down in each one of the branches. That's why we have to write it everywhere that follows from below. So we're just taking our arrow rule for what makes this statement false, and we're putting it down to all the other branches down below. Now, we just need to break down our N and M's that are on all of these right sides. What makes a ampersand false is where one of them is false. So this is going to look the exact same for all of them. Try to make this as neat as I can. It's down. It's not going to be. Should work. All right. So now we've broken that one down completely. So let's go back through and see if we can find any contradictions. I can tell you right now, I see this one right here. Clean some of this up, so stop circling things that are easier to see exactly what. So I see this P on the left-hand side and P on the right-hand side. Both up these branches, so I know both of these are going to close off because as far as I go go up to there, I'm going to see P on the left, P on the right, and same thing when I go up this branch, it's just going to be the same thing. So I know both of those branches will close off. Now, let's look over here. I've got an N on the right, and I've got an N on the left, so that one's going to close off. So those two tell me it's going to close off. And an M on the right, I've got an M on the left. So those two tell me I've got that one closed off. Now I've got an N on the left, an P on the, or sorry, N on the right, P on the left. Look at it, these, by the way. N on the left, P on, or N on the right, P on the left, M on the right, R on the right, R on the left. So actually, I already know I'm going to have everything close off in this branch. I have those two right there. So as I go up this branch, I'm going to see, oh, I've got an R and an R, so that's going to close that one off. Same thing's going to happen when I go up this branch. That one's going to close off. Same thing's going to happen when I go up this branch because I see an R. One's going to close off, and then same thing's going to happen when I go up this branch. So I'm going to see the same thing. So again, we could have stopped it up here a long time ago, and then we wouldn't have had to do any of the other things that we just did, but interest of completing it, we just followed through. So, looking at this, it is valid. All of our branches close off. So there are no counterexamples. Okay, so same thing as before. Got our premises here. We got two of them. We got our conclusion here on the right. So let us go ahead and put them in. Truth tree. P M. Start with our first premise again. So here we got parentheses closing this whole thing off and this tilde here in front of it. So that's telling us that we need to just flip it across to begin. The arrow M and so this is just getting flipped across and we're getting rid of the tilde. So now what's our main operator? Well, we've got this side and this side. The parentheses are telling me that that's whole one thing. So our main operator is our arrow. So what makes an arrow false? Well, an arrow is false where the left side is true and the right side is false. So left side true, right side false. So now we still need to break down our M and not N. So what makes an ampersand false is where one of them is false. So one of them is false. Then we just need to flip our N across the way. And so that is our first premise. So we got rid of the tilde first. Then we broke down our arrow. Then we broke down our ampersand. Ampersand. And then we just flipped our tilde across the way. So all of this is just us breaking down this one premise. So let's look at this second premise. It is a wedge. So what makes a wedge true? Well, a wedge is true wherever one of them is true. So either the left side is true or the right side is true. I got to do it in both branches. So N, not P, N, not P. Then I just need to flip the not P across like that. And so this is us breaking down this premise right here. Same thing in both branches, because again, whatever happens above has to be put down into the branches below. Then we just need to do our conclusion now, which is a not M. And so that just means that we need to put it in each of our branches as an M. M, 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 M. So all of these M's are coming from our conclusion getting flipped over and getting rid of the tilde. So all of these M's are coming from this up here. Same thing as before, anything that happens above has to be done below. So now we've broken everything down. Let's go back through, see if we've got any contradictions. I've got an M on the left and an M on the right, so I know this one's going to close off. Same thing right here. I've got an M on the left and an M on the right, so this one's going to close off. M on the left, N on the left, P on the left. There is an open branch there. Then I've got a P on the right and a P on the left, meaning this one is closed. So since I have at least one open branch, namely this one, it is invalid. And to provide a counterexample, it will be where, actually, let's check to see what all letters I've got. I've got M, N, and P. So, clean this up real quick. Get rid of these. So, M is on the left, N is on the left, P is on the left. So, they're all true. That's how we develop our counterexample. So that is problem 9. Now for problem 10. Premises are on the left, conclusions on the right. List them. P or not Q and R double arrow T. Should have given myself a little there. P Q double T. And then not P, not T, R. So let's do the first premise. I've got these parentheses here saying this is all one thing and then the P's by itself. So what makes a wedge true? It's going to be where the left side is true or the right side is true. Now, that one's alright, the whole left side here, because it's just a single letter, but let's look at this one. Well, I've got the tilde that's attaching that side, I've got the parentheses attaching that side, so that's an ampersand. So what makes an ampersand true is if both of them are true. Like that. So let's just do this not Q first. So I'm going to move this not Q over to this side, get rid of the tilde. Now I still need to operate on this double arrow. I'm to there. So remember, a double arrow is true, or both of them are true. Or both of them are false. So it's double arrow, branched out. It's tilde Q gets put with just this Q. There. Again, it's just about following a process. If you just got this procedure, you can follow it all the way, and then you just go to the next one, and then once you get all the busy work done, then you can go back through and look for the contradictions. So this premise is taken care of. Now let's look at the second premise. What's the main operator? Well, I've got this tilde attaching this P, and I've got this tilde attaching this T. So the main operator is the ampersand. I've got to do this in all of the branches down below. So what makes this true? I got to put the not P here, not T here, not P here, not T here, not P, not T. Just to show you again, same things happening because I'm breaking this down in all of the branches down below. All the branches down below have to have them broken up in them if it occurs above them. So broke that one down. Now we just need to flip these tildes across. So P, T, T, P, T. Just gotta break down until we get to the simplest letters. Come on. There we go. So the last thing we have to do now, and again, just to highlight, this is all looking the same because this is all this premise. So now we just need to do the conclusion, which is also a tilde. So we're going to take this tilde r and we're going to flip it across the way in each of our branches like that. So this is just getting put in all of our branches down below. That. And now we've taken care of that. Alright, so now we gotta just look to see if we've got any contradictions in any of these. So we've got R on the left, T on the right, a P on the left, or P on the right, and a P on the left. So we do have a contradiction there. P appears on both sides of the line. It's on the right side at one point, on the left side at another point. So that one's closed. So let's look at the next one. We've got a R on the left, T on the right, P on the right, R on the left. That looks, oh, sorry, and a T on the left. So we got two T's. Those will cancel out. Now we've got R, T, P, T, R. We got a matching pair right there. Got R on the right and R on the left, so that is closed off. So, since all of our branches close, it is valid. And that's all we got to do for that one. So in the next presentation, I'll give you some more practice problems like I did for this one, and then I'll give you the solutions again on a different lecture.